Do they? Have you been watching them? Good, good, good. Okay. What was that? You're the only view? Now, I learned a couple years ago that people can view a video and it doesn't chalk up as a view. Because I was getting on my students' case. I said, I told y'all to watch this video and I've only seen 4 views so far. Apparently, if people only watch up to a certain point and then X out, it doesn't count as a view. Yeah. So there were people who saw the video even several times and it wasn't showing up. So, yeah. Yes, first.
When you do average acceleration, don't you plug it into velocity?
Yes.
Oh, all right.
Yeah, V of B minus V of A over B minus A. Yep. Yes, sir.
Because I saw it. I had it right.
Quiz 21.
21?
I thought I gave him...
Wait, did we just do retake on quiz 21?
Yes. Yeah, I gave you 19 back.
I got 21 back. I got 21 back.
You didn't get 20. I'll look for it. You're sure you took it?
20, 21, 22.
Okay. All right, guys, let's go ahead and get started. We are going to go over a few of...
You showed it to me, but I didn't get it.
Oh, man.
This is like an old thing.
Maybe I do. I don't.
Yeah, there was a stack of about 4 things.
You guys, I need to go through.
Yeah. Okay. So, the basic idea, this is what we learned in the last class. So, I'm going to sum up, Andrew, Randy, I'm going to sum up everything that we learned. We learned that the derivative of sine of x is cosine of x. Okay? We learned that the derivative of cosine of x is negative sine of x.
I know those two.
Okay? We learned that the derivative of tangent of x is secant, that's right, is secant squared of x. Very good. Nice. Yeah. Mm-hmm. We learned that the derivative of secant of x, that's right, tan secant, is tangent of x times secant of x. I like this. Very nice. You do like those videos. I'm telling you, man, Khan Academy rocks. All right, we learned that the derivative of cosecant of x is negative cosecant cotangent. Okay? And then the derivative, d dx of cotangent of x is negative cosecant squared of x. There you go.
Oh, that is true. Yeah. That is easy.
Yeah.
Everything has an equal value.
Yeah. And we don't need the p. It's secant, secant, tangent, cosecant, cosecant, cotangent. The derivative of tangent is secant squared. The derivative of secant is secant tangent. The derivative of cotangent is cosecant squared, but it's negative. Why is it negative? Because all derivatives of co-functions are negative. That's right. Look, the derivative of cosine is negative sine. The derivatives of all non-co functions are not negative. See that? Not co, not negative. Not co, not negative. Not co, not negative. Okay? So, the derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. Okay. Yep. Yeah, well, it just helps you remember SST. Yeah. If there's some other way you can remember SST, that's helpful. Sure, I don't care. Listen, something I learned from one of my professors, my first semester of college, my very first semester of college, I learned from one of my professors. When the test hits your desk, no, well, I didn't learn that from him. That's, yeah. When the test hits your desk, you can write anything you want down at that point. So if you want to, if there are things in your head that you want to remember somewhere in the test, why don't you go ahead and write them down in the first minute you start the test? Write down as much as you can, and if you forget something, start taking the test and wait for it to hit you and then write it down. But you can write all that stuff down because the test has started, and at this point, as long as you don't have any outside materials, it's fair game to write down whatever you want. They can't stop you. You're just taking notes or using scratch paper or whatever. As long as it's coming out of your head, it's okay. So that's why what a lot of people do is if there's things, I would recommend this for things like, when anybody who's taken the biology stuff in college, by the way, biology in college is nothing like biology in high school. I think biology in college is like the hard, from the people that I knew that were like pre-med majors and stuff, the biology classes were the most devastating. Things like cellular biology and yeah, oh my gosh, that stuff is, man, the classes that they took, it was hard stuff. Calculus was nothing compared to all that stuff. It was crazy. Yeah. All right. Well, look, I'm just saying, college level biology is hard stuff from what I hear. So look, write down whatever you got to when you start a test. So that's what we learned. That's all we really learned was what are the derivatives. Okay?
I don't get the whole thing.
That's okay. Then don't use it. Just memorize them. It's not necessary. Look, you don't have to know this mnemonic. It's a mnemonic. You don't have to know it. Okay? Okay, so let's do number 4 in section 3.5. Question number 4 says, what's the derivative of x secant of x? Y equals x secant x. Okay, and what's the derivative? Well, what's going on here? What kind of function is this? Well, it's not a binomial because binomials include a plus or a minus. It's like x plus 1 is a binomial. This is a product, that's correct. It's a product of two functions. We have x times secant of x. So we have a product, therefore we need the product rule. That's correct. So we're going to do the derivative of this, which is 1, times that, secant of x, plus this x times the derivative of that, which is tan secant. That's right. Tan secant or secant tan. So tan x, secant x. There you go. There's your derivative.
And that's it?
Yeah, you're done. Now, I mean, you could factor out a secant and have 1 plus x tan, but it would really depend on what you had to do with the derivative. See, doing that could make it easier to solve. Yeah, that's correct. And I recommend you not do it either. I'm saying, though, that there are times when simplifying is not something that math teachers invented to annoy students. The reason simplifying exists is so that you can make bounds into understanding other areas of math. What if I did simplify this to secant of x times 1 plus x tan x? And then what if there was some identity somewhere that was 1 plus x tan x? I could then take this out and put the identity in there, and it might reveal new mathematical understanding. We simplify so that we can modify and move math further. But if you're just going to calculate a number, that's all you need. Now you can just put something there, and there, and calculate the value. Okay? So there's number 4. That's the derivative of x secant x. Let's do number 7, which is the derivative of 4 over cosine of x. Y equals 4 over cosine of x. There's 2 ways, actually there's a few ways, but there's 2 ways that you could solve this. What's one way? You could do the quotient rule. That's exactly right. Derivative of the top times the bottom, which is 0, minus the top times the derivative of the bottom, minus sine times 4. So it would be 4 sine on the top, and on the bottom you would have see, y prime would be sine of 4 sine of x over cosine squared, right? Does that make sense? No?
Yes, right.
Okay. Derivative of the top, 0, times the bottom, cosine of x, minus the top, times the derivative of the bottom. Okay? 0 cancels, negative negative makes positive, 4 sine of x. Right? Yeah, sorry about that. All right, so now over the bottom squared, cosine squared. Correct? Now, if we split this out, it's going to become 4, watch this, 4 times sine of x over cosine of x times 1 over cosine of x. No, I didn't. Cosine, cosine. Right? So this is tangent. Right? This is secant.
Why isn't the 4 negative?
Why would the 4 be negative? Because of the minus? Well, it's minus 4 times negative sine of x. Derivative of the bottom is negative sine of x, so negative, negative, right? All right, does this make sense? Well, there's another way we could do this. We could just say that 4 over cosine of the x is the same thing as 4 secant. Yeah, 1 over cosine of x is secant of x, right? So this is actually 4 secant of x, so that's 4 secant tangent. And it doesn't matter which way you do it. It's still going to work out. These are the same. I don't know if you were warned that calculus is trig heavy. It's usually why you learn trig right before you learn calc. Yes, sir.
So from 4 secant x, do you find the derivative to get tan of x?
Ask that one more time.
So when you got 4 secant x, I understand how you get that part.
Yes.
How did you get to the tangent of x?
Well, what's the derivative of secant of x?
Secant tangent?
Yeah.
Oh, okay.
There you go.
Oh, okay.
And the 4 is a constant. Remember, constants can be set aside, do the derivative, bring it back.
Which one said 0 though? Because the derivative of 4 is 0.
No. That would be if it was 4 plus secant. This is 4 times in a product. Now, we could, if you wanted to, we could do the product rule on this. The derivative of this, 0 times that, secant, plus this, 4 times the derivative of that, secant tangent, still turns out the same. That cancels, and it's still 4 secant tangent. Yeah. That's just a little mini proof on what happens when you do the product rule with a constant. Okay. All right. So there's that. I promise you, if you don't do all 49 of these exercises that I assigned, you're not going to be as good as you could be with trig derivatives. Number 8, y equals x over 1 plus cosine. What do you think?
X over 1 plus cosine is sine. Or no, that's...
No, you're thinking of cosine of x plus pi over 2 plus pi.
That's not what I was...
Yes, okay. Yeah. It's a phase shift. Cosine is a phase shift of sine by pi over 2. If you look at the graphs, you'll see it. You'll see it. Okay. At 1, sine starts at 0. There you go. And you're just pi over 2 away from being at 0. Yeah. Okay, so here, so let's... Go ahead, what are you thinking? Say it out loud. Quotient rule. Yeah, sure. All right. So y prime is going to be the derivative of the top, 1, times the bottom, 1 plus cosine, minus the top, times the derivative of the bottom. Now, the derivative of 1 is 0, plus derivative of cosine, negative sine. Right? Over the bottom, 1 plus cosine squared. Okay? And now, let's see here. Now, actually, I would just leave it like this, honestly. I would change this to a plus because of the negative sign, and then get rid of the 1. Yeah, see, that's the thing. What you can do here is, watch this. You can split this up. You got addition here. So you can do 1 plus cosine of x over 1 plus cosine of x squared plus x sine of x over 1 plus cosine of x squared. Now we can cancel a 1 plus cosine of x, and now all we have left is 1 over 1 plus cosine of x plus x sine of x over 1 plus cosine of x squared.
How did that help?
It didn't help us now. What it did was, if you were trying to get somewhere, if this was an identity that you wanted to replace, I keep bringing this up, this idea of replacing an identity, okay? If you saw cosine squared of x plus sine squared of x somewhere in a formula, what could you replace that with? A 1. Well, what if it didn't quite look like this? What if it was some messy thing, but you could rearrange everything to make this in the mess? Then you could put a 1 in and it would be less messy. Less of a mess. Okay? All right, the reason we simplify is so that we can make things less messy, usually by putting in identities of some sort. Okay? All right, so that was number 8. I'm not sure if I should do any more right now because we got to get through today's new material. We've only got 20 minutes.
See, I feel like
Go ahead.
not learn at all with videos. I have to have someone in front of me teaching me, and I think that's why I only understand stuff until after the fact, because like I'd have to have someone like teaching me, and you mostly rely on the videos for the quizzes rather because
I don't feel like I rely on the videos at all.
Well, I mean,
I feel like I rely on the exercises
but
for the
we rely
quizzes.
on the videos to like work through it, because with the exercises we don't have like someone working through them. You know?
Right, but what you do have is this. Learn material, do exercises. Whole day of, hey, Mr. Ryan, can you explain number 17 to me? Then quiz. I think what's happening is people are doing the exercises after the day they could be asking me questions about the exercises.
Well, I never
That's a problem.
do them.
Well, you have to work on them. And now that you have access to the solutions manual,
I don't have like 5 hours a day to go through all of this stuff.
well, yes, I can appreciate that. But you should have at least an hour and a half a day to go through it all.
I stay busy.
Right, but that's on you. That's your economics. That's not my economics. My economics is that I have to figure out. It is economics. Would you agree that your time is scarce? Would you say that the demand on your time is greater than the supply of time you have? Economics. Every single decision in the universe is an economic decision. Every single one of them. First thing I learned from my microeconomics professor. And he's right. He is totally right.
Even the decision to wear pajamas.
The decision to wear pajamas. How many pairs of pajamas do you have? Okay, you have a lot. How many can you wear? How many can you wear at one time? Okay, well, you have to make a decision then. You have a limited amount of experiences to wear the pajamas and 5 or 20 options, right? So they all want to be worn, but only one of them can be worn. That's an economic decision. No, I didn't tell her. I'm helping her understand how everything is an economic decision. You know, you want to go to lunch. Most people think going to lunch is an economic decision because it costs money. No, that's not why it's an economic decision. How many times do you go to lunch in a day? How many options do you have? How many of them can you pick? There you go. Economic decision. You are giving up. What you're talking about here is it's not about the money. It's about what is called the opportunity cost. It is what you are giving up. To have Taco Bell, you have to give up McDonald's. To have Chick-fil-A, you have to give up Moe's. See what I mean? It's a big deal. Now, what if you want to go to lunch with a friend, and this is a friend that you really want to have lunch with this person, and they have their heart set on having Chick-fil-A, and you want to have Moe's. Right, I understand that, but here's the thing. Now, what are you giving up to force them to go to Moe's? Are you giving up as good of a time that you could have with them because they're disappointed that they didn't get to go to Chick-fil-A? there are dozens of things that are being affected by every decision that you make, which is why when people get bent out of shape over politicians making decisions in Washington, people are like, oh, it's so simple. Why are they taking this away from me? No, when they pull a string, 47 different plates move. Okay? It's not that simple. You only see one of the plates. And you know it's attached to that string, but you don't know what else is attached to that string. So don't get so bent out of shape because it's not as easy as it looks. That's why I don't talk about politics. I don't criticize them. I don't vote for them. I don't do anything with politics. I figure let them do their thing, and I'll just live in the world that they create. That's good enough for me, and I'm real happy about it. What's that? That's what we're getting to, chain rule. Yeah. All right. All right. All right. Excellent segue there. Okay, the chain rule. The chain, no. Yeah, actually, in a way, it is a sort of a chain reaction. Okay.
I learned the chain rule, but I forgot it.
Okay.
I learned it.
You did good.
The video guy said it, and then he was like,
Yes. Okay, here we go. All right. The chain rule is arguably the most important of all of the derivative rules. Arguably, it is the most important. Why? Why would I say that? Well, okay, I can't really back that up in the sense that to do the chain rule, you have to have some of the other rules. So you can't successfully complete the chain. Well, actually you can. It's a pain in the butt. Yeah. The chain rule affects other things in calculus. So what I'm going to show you other derivative procedures in a few weeks that are basically applications of the chain rule. The AP folks, the people that write the AP questions, they love the chain rule. I love the chain rule. If all the AP Calc teachers and all the people that write the questions love the chain rule, then even if you don't love the chain rule, you should at the very least be good at the chain rule. I have found that many students just avoid the chain rule altogether. They say, oh, that's a chain rule problem, I'm moving on. Don't do that. It's a very simple rule. I'm going to show you 2 ways to understand it. I'm going to show you a way to understand it, and then I'm going to show you a way to do it. Okay? Both of them are practical. Okay? So here we go. Let's say, I'm going to say it. The chain rule is a rule that is the derivative rule. It is the derivative rule for composition functions. Whenever you have a function that is a composition of two or more functions, you have to use the chain rule. You should use the chain rule. There are other ways of pulling it off, but they are all more difficult than the chain rule. Yes, ma'am. Composition function is something like this. The square root of x squared minus 5 is a composition function. Okay. It's got 2 kinds of functions. It's got a polynomial plugged into a radical. It is basically the square root of x and x squared minus 5, where x squared minus 5 are shoved in for x. Right? Okay, so if f of x equals x squared, or the square root of x, and g of x equals x squared minus 5, then f of g of x is where g of x is shoved into the x for f of x, square root of x squared minus 5. Okay? And if you want the derivative of a composition function, you are going to want to use the chain rule. Here's another big difference. I'm just erasing this bottom part here. Do you know what the derivative of sine of x is? Derivative of sine of x? It's not a cofunction, cosine of x. Okay? Cosine of x. How about the derivative of sine of 2x? Not cosine. You've got to use the chain rule. This is a composition function. Instead of just having an x, you have a whole new function, 2x, plugged in for x. The basic idea with the chain rule is this, is if you're looking at a function, can you pick up the cat for me? I'm sorry. If you're looking at a function and where you would normally see just x, you see something other than just x. You see 2x. You see x squared. You see the square root of x. Is this okay? All right. I'll give you one more example of a chain rule problem. X squared minus 5 to the 5th power. Now, you could expand this. It would be a pain in the butt. Pain in the butt to expand this. It would take you a very long time. Or you could just do the chain rule. Yes, this is the same thing as x to the 5th and x squared minus 5, where x squared minus 5 is plugged in into the x in x to the 5th. It's two separate functions that have been put together into a composition function. Okay? Okay, so let's look at the chain rule. I'm going to give you the algebra for it today, and then I'm going to give you the simple procedure tomorrow. I'm giving you the algebraic explanation today. Okay? And you can use the method you use today, in my opinion, is the best method to use until you are so good at it that you can then just use the simple rule. Okay? Oh, that's true. So that means you have a whole week. No, you have a whole week to practice these.
That's great. Yay. Awesome.
I'm so happy.
All right. Let's say, here's what we're going to do. We're going to do sine of x to the 3rd power. We're going to say that y is equal to sine of x to the 3rd power. And we want to know what dy dx is. Okay? We are trying to find dy dx. Okay? The procedure I'm going to show you is often referred to as U substitution, the letter U. U substitution. U substitution. U substitution. Okay? All right. The first thing you're going to do is this. If you want to identify the derivative of this, the first thing you can do is you can take whatever the inside function is. When we come back on next Monday, okay, I'm gonna refer to these things as inside and outside. Okay, now if one of these was the inside function, one of them was the outside function, which one would you call the outside function? Sine, right? Yeah, sine of x would be the outside function, right? What would you call the inside function? X cubed, right? It's the function that has been plugged into the other function. Okay? So typically what you do with U substitution is you take the inside function and set it equal to the letter U. So we're going to say that U equals x cubed. There you go. Is that simple enough? Because y is equal to sine of x cubed. We can't make y equal to sine. We can't make y equal to x cubed because y is not equal to x cubed. It's equal to sine of x cubed. Okay. Are we okay so far? Is that easy enough? Step 1. If you're a steps person, step 1. Set the inside function equal to u. Okay. Step 2. What I would do next is I would rewrite my original function with u substituted in for the inside function. So y is equal to what? Sine of u. Does that make sense? Does all this information up here, is it all consistent with our starting function? Okay? This is why we do things like simplify, so that we can substitute in identities. You have created an identity. Identity meaning these two things are algebraically equal to each other. Okay, so now, you're going to do the derivative of both pieces. Now, what would the derivative of this one be called? U prime or du dx. That's right. Du dx. And what is du dx? 3x squared. And now we're going to do the same thing over here. By the way, I'm almost done, Marquise and Randy, I'm almost done. What's the derivative over here going to be called? What's the designation going to be? Y prime or dy, not dx. Dy du is cosine u. Cosine of u. Right? All right. Ready now? Here's the fun part. Dy dx is equal to, I'm just going to make the true statement, then explain it to you. Dy dx is equal to du dx times dy du.
I will take your word for that.
No. You don't have to take my word for it. I'm about to prove it to you. Look, multiplication. How do we solve multiplication? How do we solve multiplication of fractions? Multiply across, right? So du times dy, right? Over dx times du. And now, algebraically, what can we do? Cancel the du's, and what do we have left? Dy dx. So now all you have to do is multiply these two things together. So dy dx is going to be equal to 3x squared times cosine of u, correct? Oh, you can put them right next to each other. You're good to go, but you're not quite done yet. No, you're done. This is derivative. What does u equal?
X cubed.
X cubed. Yay, there's a derivative. Sure. Although these guys got to pack up. Yeah, I'll leave this here for a minute. Randy, Marquise, please watch this video again, just the end of it so that you can see. I mean, what did I spend? 15 minutes on the chain rule? Okay, watching the last 15 minutes will really make this better for you, especially while you're doing the homework. Okay? All right, let's do one more. Can I erase this now, or are we? I'm waiting. Does it seem easier than the intimidating thing it sounded like I was talking about? Yeah, it's really easy. I love the chain rule. And when I see you on Monday, I'm even going to show you an easier way to do it without writing all this stuff. But it'll be better for you if you have done a whole bunch of homework by the time you come in. Okay? It will be better for you if you have already done a whole bunch of these. Especially the examples. All right, I need to go ahead, and if I'm going to get another example in, I'm going to have to... Okay, so let's say that y is equal to, let's do that other one. Let's do that x squared minus 5 to the 5th power. Okay. Can somebody, Juan, can you shut that door, or Bianca, or somebody? Okay. What would our first step be here? Okay, good. Yeah. U equals what? X squared minus 5. Yep. And now what?
Y is equal to u cubed.
Nope, it's whatever this is. Yep, u to the 5th power. Yep. And now what should I do? I'll wait for you guys.
Take the derivative of...
Okay? Du dx is equal to 2x. dy du is equal to 5u to the 4th. There we go. Now do you see it? Now that I've shown you that little tiny proof thing, now do you see it? That when you multiply these two by each other, the du's just cancel out and all you have left is dy dx, which is what you're looking for. So now what's dy dx going to be equal to? 2x times 5u to the fourth.
And plug in x squared minus 5.
And plug in x squared minus 5 for u. X squared minus 5. Now, see this, or excuse me, to the fourth. Now, this can be cleaned up, right? We can do one thing to clean this up, can't we? Well, we don't want to distribute, because look, we got a fourth power up here. But look what we have. We have a 2x times 5. 10x. Yeah. So really, like if this was a multiple choice question, they wouldn't have 2x times 5. They would have 10x and then x squared minus 5 quantity to the fourth power. And now that is your derivative. That's the chain rule. That's it. It is a beautiful algebraic thing. This is the derivative of that. Yep. And if you wanted to know where this has any minimums or maximums, you would just set this equal to 0. And I automatically see 1 at 0. The other one's going to be at the square root of 5, I guess. Yeah, because look, square root of 5 squared is 5 minus 5 is 0. Sorry. I've been doing math for 6 years. Yeah. Please watch this video. I'm going to go shut it off right now.